This experienced factory worker is assembling General Motors' latest fifth-generation small-block V8 engine. Much of the final assembly of these V8 engines is performed by hand, with skilled technicians using pneumatic torque wrenches. So, welcome inside the Tonawanda Propulsion Systems plant. This is where engines are assembled for vehicles such as the Chevrolet Silverado, Corvette, Sierra, Suburban, and Cadillac Escalade. Inside the factory, employees make around $40 per hour on average. Since beginning operations, this factory has produced an incredible 75 million engines for General Motors vehicles. Because of the huge number of engines produced, occasional recalls or service bulletins do occur, but engine-specific recalls are relatively rare. The very first small block, a 265 cubic inch V8, debuted in the Chevrolet Bel Air. The GM small block is the longest continuously produced V8 engine family in history. Since its introduction in 1955, more than 100 million small block V8s have been built. Compact, powerful, and affordable, it quickly earned the reputation as the engine that changed everything in American performance cars. Its compact size and light weight made it easy to fit in nearly any vehicle, from cars and trucks to race cars. The simple pushrod design made the engine durable, low profile, and capable of producing strong torque. Right now, you're watching the finished engines being moved to the main assembly line, where they will be installed onto the vehicle's chassis. Throughout the factory, all engines are moved either on these conveyor belts or by automated guided vehicles. Transfers between workstations are closely monitored, and every step must be precisely coordinated. The process you're watching now is called the marriage. This is the moment when the heart of the car, its engine and transmission, is joined with the body, creating a fully functioning, road-ready vehicle. This step is critical as it forms the backbone of the car and ensures everything is properly aligned for performance, safety, and durability. Once completed, the vehicle continues down the assembly line for the installation of interior, exterior panels, electronics, and final quality checks. But now you're watching powertrain production in Romulus, Michigan, where the renowned HFV6 engine is built. It produces the 10-speed automatic transmissions used in vehicles like the Chevrolet Silverado, GMC Sierra, Cadillac Escalade, Chevrolet Tahoe, and GMC Yukon. The 10-speed transmission is a key component for full-size trucks and SUVs, helping with performance, efficiency, and competitiveness in a demanding market. Producing both a modern V6 family and advanced 10-speed transmissions under one roof allows GM to integrate powertrain manufacturing more tightly and respond to demand shifts in both engines and transmissions. Certain early versions were subject to timing chain wear and cam phaser issues in specific conditions, such as extended oil change intervals or heavy-duty use. The HFV6 engine lineup gives GM flexible powertrain options for mid-size vehicles and luxury brands. This is the assembly of the Chevrolet Corvette 6.2-liter V8 LS9 engine. Each LS9 engine was hand-built at GM's Performance Build Center in Wixom, later relocated to Bowling Green, Kentucky. A single technician assembled each engine, and some units feature a plaque with the builder's signature, a unique mark of craftsmanship. When it debuted in the 2009 Corvette ZR1, this engine produced 638 horsepower, making it the most powerful production engine GM had ever built. With only around 4,700 Corvette ZR1s produced between 2009 and 2013, the LS9 remains a rare collector's item. The assembly begins with a lightweight aluminum engine block, carefully cleaned, inspected, and precision machined. Cast-in iron cylinder liners are incorporated for strength and durability, while 6-bolt main bearing caps help the block withstand high boost pressures. Unlike most LS engines, the LS9 uses a dry sump system, typically reserved for race cars, ensuring consistent oil flow even during high-speed cornering. The rocker arms, push rods, and lifters are installed with precise preload settings. Every component is torqued to specification and carefully checked for proper clearance. Next, the factory technician attaches a nameplate, Wixom Performance Build Center, assembled with pride by Mike Priest. The block is made from 319 aluminum, designed for both lightweight performance and toughness. A hydraulic roller camshaft is installed and tuned for both performance and smooth street drivability. The timing chain, tensioner, and gears are carefully fitted to ensure precise engine timing. Titanium rods are ultralight and extremely strong, usually found only in exotic sports cars. Their use in the LS9 is part of what allows it to rev high, while handling massive supercharged torque. This is General Motors' Romulus engine plant, a facility with deep roots in General Motors' powertrain operations. As of around 2020, the Romulus engine plant employed roughly 1,400 hourly workers and spans approximately 1.4 million square feet. In the 1980s, it transitioned to engine production, and since then has built over 10.8 million V8 engines and more than 6.6 million V6 engines. The Tonawanda engine plant in Buffalo produces over 1,500 V8 engines every day. Highly automated processes, such as head assembly, are extremely efficient, often completed in under a minute. You are now watching the engine being mounted to the transmission and lowered into the vehicle's chassis. To position the engine over the chassis and lower it into place, workers use a crane integrated into the roof of the factory hall. As you can see, these engines are truly massive, one reason why vehicles powered by them command higher prices. This is Saginaw Metal Casting Operations, a long-standing GM foundry with a history dating back to 1919. The casting process typically begins with molding, which can involve green sand, dry sand, semi-permanent molds, or permanent steel molds. Once the mold is prepared, molten aluminum is poured into the mold spout. This facility produces engine blocks and cylinder heads using both precision sand and semi-permanent mold casting techniques. It plays a critical role in supporting GM's engine plants, supplying aluminum heads for engines such as the 3.6-liter. The metal flows downward through runners and gates toward the head deck surface, filling the mold cavity to create the desired shape. For precision applications, such as lost foam casting, a foam pattern is used that vaporizes when exposed to the molten aluminum. This combination of advanced casting methods and skilled craftsmanship ensures that each engine component meets GM's strict quality and durability requirements. The aluminum takes the place of the pattern, producing highly accurate, detailed castings that meet the demanding standards required for modern engines. Now, for comparison, we move to the Bentley factories in the UK, where, in addition to V8 engines, the massive W12 engines are also assembled. This gives you a chance to compare working conditions in automotive factories in the United States and the United Kingdom. Right now, you're watching factory workers manufacture Toyota's 2.4 and 2.5-liter four-cylinder engines. These engines are entirely made in the United States and are renowned for their reliability. This assembly line worker's name is Scott. On the main assembly line at Toyota Motor Manufacturing, West Virginia, employees earn an average of approximately $25 an hour. When running at full capacity, the plant produces a transmission every 25 seconds and a four-cylinder engine every 30 seconds, among the quickest production speeds Toyota achieves worldwide. Here inside Toyota Motor Manufacturing, West Virginia, 2,070 employees are working on engines and transmissions. This is only Toyota plant in North America that builds both engines and transmissions under one roof. The plant was the first Toyota facility outside Japan to produce 10 million powertrain units. These engines are widely considered reliable in everyday use, often lasting 200,000 plus miles with good maintenance. Many owners report long service lives in vehicles like the Toyota RAV4 and Camry. Some earlier versions, especially older 2.5 designs, had oil consumption, misfires, or cooling system complaints depending on model year. Inside this West Virginia factory, employees must follow strict safety dress codes and policies. Toyota manufacturing plants in the U.S. are not currently unionized by the UAW. Toyota historically has not had UAW representation at most of its U.S. factories, and workers at Toyota facilities are generally non-union employees. This is also the only Toyota facility in North America that produces hybrid transaxles, a crucial part for hybrid models like the Sienna and Highlander. In the process you're viewing now, factory workers and robots operate in close coordination. Programmable robotic arms move and install smaller components, while workers are responsible for final assembly and enclosing the engine. Right now, you're watching a senior quality control technician inspect the finished engines using a standardized checklist. Once approved, the engines are transported to the main warehouse by forklift. There's no broad current recall specifically targeting the 2.5-liter engines for catastrophic failure in the U.S. Most recent major recalls have involved other engines. The 2.4-liter turbo engine powers the Camry, Toyota RAV4, and Lexus NX. The 2.5-liter gasoline engine is used in the Camry, RAV4, Corolla, Corolla Cross, Lexus ES, and Lexus NX. The manufacturing process of each engine is, above all, a logistical challenge. Every component must be in the right place at a precisely scheduled time. The supply chain is critical to keeping this massive operation running smoothly. From the control center, operators oversee the entire factory and monitor the full manufacturing process. Each workstation consists of several workers working together as a coordinated team. Every station has a supervisor responsible for quality. Inside this Toyota factory, women have historically made up a significant minority of the workforce, around 30% of manufacturing employees. Toyota also highlights women in leadership and skilled roles at its West Virginia facility, including team members recognized for excellence in manufacturing. This Toyota engine contains roughly 2,000 to 2,500 parts, if you include every bolt, washer, and sensor. If you count only the main mechanical components, the total is closer to 500 to 800 parts. Last year, Toyota, including Lexus, sold about 2.3 million vehicles in the United States. That ranked near the top of the market, just behind General Motors and roughly on par with Ford. But now we'll move from Toyota's US factory to the Descherd powertrain assembly, where V8 Titan engines for Nissan vehicles are produced. The plant occupies hundreds of acres, with over 1.1 million square feet of covered production space, making it one of the company's largest manufacturing complexes. It provides the engine and powertrain backbone for many US-built Nissan and Infiniti vehicles, supplying 4, 6, and 8-cylinder engines, as well as electric motors for select models. Since 1913, and Henry Ford's concept of automobile production, not much has changed. The facility is capable of producing up to 950,000 engines each year, along with 1.1 million crankshaft forgings, while managing critical processes such as casting, forging, machining, assembly, and testing of engine blocks, crankshafts, and other components. Descherd remains the sole US-based engine production site for Nissan, with every US-built Nissan vehicle using a gasoline engine relying heavily on this plant. By combining casting, forging, machining, assembly, and testing under one roof, Descherd reduces logistics complexity and enhances quality control. Unlike many engine factories, Descherd performs comprehensive hot fire testing, where engines are filled with fluids, connected to stationary dynamometers, and run under load to verify compression, timing, noise, vibration, and emissions. The Kokomo engine plant was created by repurposing what had been an idled transmission facility to produce the 2.0-liter turbocharged inline-4 engine. This engine is part of Stellantis's global medium engine family and powers vehicles such as the Jeep Wrangler and Jeep Cherokee, bringing US-based production for this unit that had previously been built abroad. While this isn't the engine plant itself, the Kokomo casting plant nearby has a long history and is globally notable for manufacturing aluminum castings for engines and transmissions. Kokomo is home to multiple Stellantis powertrain facilities, including transmission plants, a casting plant, and the engine plant itself. Together, these sites produce a wide range of components like transmissions, engine blocks, and cast aluminum parts for both engines and driveline systems. It is one of the largest die casting facilities in the world, and the only plant in Stellantis's global footprint that casts components for both engines and transmissions. The Kokomo powertrain complex is not static. It continues to evolve with investments in new engine production, electrified drivetrain components, and manufacturing technologies to meet changing automotive market demands. At the Kokomo engine plant, all sub-assemblies are brought together for final engine or transmission assembly. Workers and automated systems install pistons, crankshafts, cylinder heads, valve trains, and ancillary components. The process often begins in the nearby Kokomo casting plant, which produces aluminum and other metal castings for engines and transmissions. Engine blocks, cylinder heads, and other key components are cast using high-pressure die casting and precision molds. After machining, parts are cleaned, inspected, and moved to sub-assembly areas. Engine sub-assemblies may include cylinder heads, camshafts, valve train components, and oil pumps. After assembly, every engine or transmission undergoes rigorous testing. For engines, this includes hot fire testing, where the engine is filled with fluids, mounted on a dynamometer, and run under load to verify compression, torque, timing, and vibration. Transmission units are similarly tested for smooth shifting, gear engagement, and durability. These tests ensure each unit meets Stellantis' performance and reliability standards. Once a powertrain passes quality control, it is packaged and shipped to vehicle assembly plants, such as Jefferson North Assembly, Toledo, or other U.S. Stellantis assembly locations. Kokomo's integration of casting, machining, assembly, and testing within a local complex reduces transportation time and ensures rapid delivery. This network includes the Kokomo engine plant, Kokomo transmission plant, Kokomo casting plant, and related machining and assembly operations. The Kokomo powertrain operations aren't just one building. They're a set of interconnected facilities that together form one of Stellantis' most important engine, transmission, and powertrain manufacturing hubs in the U.S. The Kokomo transmission plant has a long history of output and has produced millions of transmissions over its lifetime. For example, the plant produced its 1 millionth 8-speed automatic transmission for vehicles like the Jeep Grand Cherokee, Dodge Charger, and Ram 1500. According to local economic data, Stellantis operates 5 powertrain facilities there, including the engine plant, casting plant, and several transmission plants. And together, these facilities employ around 6,600 people. Earlier, Stellantis statements also noted that the company has more than 7,000 employees in Indiana across its operations, including Kokomo and nearby locations. With many of those jobs in casting, machining, and assembly roles directly tied to powertrain production. It has been operating for decades and remains the only casting facility in Stellantis' global footprint that supplies parts for both engines and transmissions. Right now, you are watching the Chevrolet Traverse being manufactured inside the Lansing Delta Township Assembly Plant. This facility also builds the Buick Enclave and GMC Acadia, sharing the same production architecture. There are also limited versions assembled for certain export markets, including production in China for local demand. But the US and global mainstream supply comes from Michigan. The Chevrolet Traverse entered production in 2008 as a 2009 model year vehicle. It originally began assembly at GM Spring Hill Manufacturing Plant in Tennessee, before production was transferred in 2010 to the Lansing Delta Township Assembly Plant, where it has remained ever since. The Lansing Delta Township plant has produced over 3 million vehicles total, including multiple generations of the Traverse. The facility operates as a high-volume SUV plant, producing vehicles on flexible assembly lines shared with other GM 3-row crossovers. This shows the Chevrolet Silverado in its testing and development phase. Engineers and technicians evaluate early prototypes under controlled factory conditions, checking durability, performance, and system reliability. Every component is examined, from the powertrain and suspension to electronics and safety systems. The result is a truck engineered not just for production, but for long-term durability and real-world performance. Right now, you are watching dynamometer testing during the vehicle development phase. This is the General Motors Fairfax assembly plant. The plant has a long history dating back to the 1980s, originally producing vehicles under different GM platforms before its current lineup. The Fairfax plant employs approximately 2,500 to 3,000 workers, including production staff, engineers, and support teams. It operates on multiple shifts, allowing continuous production throughout the day. The workforce includes highly trained technicians, working alongside robotic systems for welding, painting, and assembly. The plant primarily produces the Chevrolet Malibu and the Cadillac XT4. It is part of General Motors' advanced North American manufacturing network focused on efficiency and flexible production. The facility has undergone major modernization in recent years, including investments in new tooling, automation, and body shop upgrades. This is how assembled vehicles go through the final quality inspection stage using LED light tunnels. General Motors is one of the world's largest automakers, but its success is very different depending on the region. It is strongest in North America, much weaker in Europe, and mixed in Asia. In 2026, General Motors sold about 2.8 million vehicles in the United States, giving it roughly a 17% market share. This makes GM one of the top 1 to 2 automakers in the country, competing closely with Toyota and Ford. General Motors holds around a 6 to 7% global market share in recent years and sells roughly 6 million vehicles worldwide annually. The majority of its profits come from the United States, particularly through high-margin trucks and SUV. Additional key earnings come from its premium brand Cadillac, as well as select operations in China.
This is the General Motors Arlington Assembly Plant in Arlington, Texas. It is the exclusive manufacturing facility for the Chevrolet Suburban and Chevrolet Tahoe. Opened in 1954, it has grown into one of GM's largest and most important assembly plants, specializing in full-size SUVs. Only production site worldwide for the Chevrolet Suburban and Chevrolet Tahoe, supplying customers in North America and more than 30 international markets. The plant also manufactures the GMC Yukon, GMC Yukon XL, and Cadillac Escalade, making it GM's center for full-size SUV production. Covers approximately 4.4 million square feet on a 250-acre site. Employs roughly 5,600 to 5,700 workers across 3 production shifts. Production runs 24 hours a day, 6 days a week, with a new vehicle leaving the assembly line about every 60 seconds. The Arlington plant has produced more than 12 million vehicles since opening, reaching the milestone with a Chevrolet Suburban. In 2023, the Arlington assembly plant achieved its highest monthly production record in nearly 70 years, producing over 34,000 SUVs in a single month. Before every Chevrolet Tahoe and Suburban leaves the Arlington assembly plant, it undergoes a series of rigorous quality inspections. These inspections are designed to ensure the vehicle meets General Motors' high standards. These standards cover safety, performance, and craftsmanship. In the final stage of production, trained inspectors carefully examine each vehicle's exterior finish, interior fit and finish, electronic systems, and mechanical components. These parking lots act as a temporary staging zone where thousands of newly built vehicles are organized before shipment. Each SUV is systematically parked in rows, often grouped by model, trim level, destination, or shipping schedule.